Okay, I've had my hands full this week. Tuesday morning, 3:31 a.m. Miss Emma Ashbrook was born. Thank you.
I was wondering what the emergency was.
Yeah, so I hope that was okay that we did video class instead. She's cute. Chandler Regional. There's another one. I wish it were brighter. You'll see in the video it's brighter if you want to watch the video. No, I mean this. I'm recording this, so. Okay. Yes. Now she's adopted, so we have gotten to know the birth mother over the last 3 months, and we got to be in the hospital there. That first picture was she was an hour old in that first picture. Yeah, she's an hour older. Yeah, she's okay. Let's see here. So you guys want to do 79? Is that right? Okay, 79. It said it rose from 8 feet to 14 feet over 4 hours. Is that right? Okay, so what are these? So exponential growth, exponential functions is all about what? It's all about, there's the centerpiece we're saying. It's all about, okay, repeated multiplication, and then repeated multiplication of the growth factor. So if it goes from 8 to 14 feet over 4 hours, we want to start with the easiest growth factor we can find, which would be what? So now we're talking about many growth factors, right? In the same situation, we can have different growth factors. So what growth factor should we?
The change in feet over 4 hours.
Okay, so which growth factor? The 4-hour growth factor. So the 4-hour growth factor is the number that you'd multiply 8 by to get 14, right? Because it'd be the multiplier to give you the quantity 4 hours later. So what number do you multiply 8 by to get 14? Now, you don't need it. So how would you find it? What is that number? 14/8, right? So this is 14/8 is the 4-hour growth factor. Okay, and so then we're asking, we want the hourly growth factor. So if the hourly growth factor is B, so then what? B times B times B times, what would that equal? That could be to the 4th. And what would that equal? 14. Would it equal 14? That would be the same. Multiplying the hourly growth factor together 4 times would be the same as multiplying by what? This is our image of repeated multiplication, right? So if I got an hourly growth factor, if I multiply it by 4 times, I've just advanced the output how far? How far have I advanced the output? How many hours? 4 hours. So this would be the same as, b to the 4th is the same as what? 14/8, the 4-hour growth factor. Do you see that? And so what is our hourly growth factor? 14/8 times 1/4 to the 1/4. Let's get a value for that. Let's get an approximation for that. So take 14/8 and take it to the 1/4. This is our hourly growth factor. What's that? Is there one more decimal place? 1.150? Okay, so what we're trying to get at is not trying to memorize rules and have a slick procedure for every type of problem, but have this kind of thinking. So this is the kind of thinking that I'm trying to train you in, because that kind of thinking can allow you to solve any problem with these exponential equations. Okay, that's the name of the game. So if you're looking for rules and procedures, you know, they're only going to work for that particular type of problem. And then what if you forget the rule? Or what if you mess up the procedure? Okay? If you understand this idea, you have this image of what growth factors are like, you can solve anything. Okay? You can solve anything, and it's based on your reasoning, and that is trustworthy, right? If you got good reasoning, that's always trustworthy. A rule, something to memorize, don't trust that. Okay? So does that make sense? So that's the 1 hour growth factor. And so they said, that's part A. So write a function that relates the depth d of the river in feet to the number of hours since the storm began in the form f of h. Did they tell you an initial depth? Oh, normal depth was 8. Okay, thank you. Normal depth was 8. All right. Okay, so if the normal depth was 8, that's our initial value. And every hour, we would multiply by what? Yeah, 1.150. So to the h, number of hours, and that's our f of h. Is that right? Is that part B? Okay, and then we worked through the math, and we said, well, we could think of this as, so this is the multiplier for 1 hour at a time, but we could think of this as accumulating continuously. Okay, and if it's accumulating continuously, it could also be written this way: 8 times e to the, are they calling it k in this problem? E to the kh, right? So we want to rewrite it in that form. So we would have, therefore, this growth factor 1.15 is the same as e to the k. And e to the k is the K is what we call the continuous rate. Is K going to be less or greater than 1.15? Some are saying less, some are saying greater. What about over here? Less or greater? Okay. Well, about the same, that's true. But they're not equal. Which one is going to be? Okay, so we still got dissension in the ranks. Remember what the continuous rate is. The idea of the continuous rate is that this continuous rate K combined with continuous kind of what we think of as compounding. Hold on a second. Hold on a second. Okay, so K combined with continuous compounding will result in will give us an actual percent increase of how much per hour? In this case. So what's the actual percent increase per hour? It's actually increasing exactly how many percent per hour? We should all know this. What is this increasing per hour? 15%. 15.0%. So this continuous rate is it's the percent that if you combined it with continuous compounding, the net result would be that your population would go up 15%. So now that we understand that, should K be less or greater than 0.15? So you're going to take a greater number And now you're going to combine it with continuous compounding. So say it's 0.16. You're going to take 0.16, you're going to combine it with continuous compounding, and then the result will be a lower rate, 0.15. Does it make sense? Does it make sense? Remember what happens when we compound something? We get a little bit more increase, right? Right? So K should be less, because when you combine it with the continuous compounding, it should come out to the net result, the actual increase of 15% a year. Okay, so what do we have to do? We have to, what we're after K. What kind of thing is K? We know what E is. E is this number, so E doesn't phase us because we know it's an exact number like pi. We've got to solve for K. How do we do it? Natural log, what's that? How do we solve for an exponent? Okay, all the homework turned in? We'll return to it after the quiz because I want to see what you're going to do. All right, so books and notes away, no calculator. Calculators away. Everything. Okay, no talking, eyes on your own sheet. Okay, books and notes away, no calculator, just something to write with. You work by yourself. Eyes on your own page. What was that about? How to spell your name? Make sure you put your name on it. Okay, all talking stops. No, mathematical statement. Like an equation or an expression. Yeah. Okay, so in order to solve for K, it's an exponent, we need a log. What log is it? It's the log, it's the exponent of E that gives 1.15, so that's the log base E of 1.15. Our log base E is natural log of 1.15. That gives us this number 0.14. So 14% combined with continuous growth has the net effect over 1 hour of a true increase of 15%. The value of B is a growth factor. The value of k is a rate as a decimal. So there's two things that we have to understand here. The first is how this continuous rate works. We combine it with compounding continuously, and we get this greater rate if it's growth, or this greater percent increase. Oh, did I make a mistake?
40% continuous continuously then get the actual percentage increase of 15%.
Yeah.
Related?
We're not changing the situation. The situation is the same. It's just two ways to talk about it. You can talk about the situation as it's growing 14% continuously, and then, or you can say it's growing 15% per hour. Okay? The situation is the same. It's just two different ways of describing it. It's growing 14% continuously, or it's growing exactly 15% every hour. Okay, any questions on, so rewriting it in that form, it would be e to the 0.14. So you could say 8 times 1.15 to the h, or 8 times e to the 0.14h. And those both give the exact same profile of growth, just two different ways of looking at it. As per hour, and as a continuous rate. As a continuous rate. Questions on number 79? Okay, so what I want you to work on is practicing this log stuff. Go back to page 165. Okay, I want you to do number 3 and number 4. And notice that 4 has a part D on the next page. And then number 6. Once again, number 3, number 4, number 6. Notice that number 4 has part D on the top of the next page. Six. 3, 4, and 6. 3, 4, and 6. What is the approximation for part A, number 3? Okay, check your answer to number 3. I'm going to take this off in about 20 seconds. I'll take this off. Keep working. So if you have a question about this, catch me in a second. I'll make another round. But catch me in a second if you've got a question about this. Did you get an approximation for T and for C? Negative what? For C, negative. Negative 57.63. Let's see that at all. I know how to do that. Which is the year what? Okay, check number 4. I'll make it a quick round if you got a question. Check number 4. Somewhere in this area here.
I said 1938.
Did you say 8? I just misheard you. Okay.
You're just a little tired.
I am a little tired.
I understand.
Okay, how's number 6 going? Any questions on 4 before I erase it? Does it make sense? D is going to be the same thing, but you're going to have, the only difference is you'll have, right here, you'll have 400. What years you get? 2025. You get 2025 for part D. 2025. Okay. All right, so the decay is a little harder. We know it's a little harder because seeing the percent increase is a little tougher. Okay, so this says a continuous percent rate of 17%. So does the amount of caffeine go down 17% every hour? Yes or no? Is that the actual percent change per hour, or is it something different? That's the continuous rate, okay? That's the continuous rate. So if the rate is a continuous rate of 17%, what is our value of K? K will be negative 0.17. Remember, K is as a decimal. That number that we're going to put into the e to the k, that's a decimal version of the continuous rate. All right, so let's just do part C first. It started at what? 80? So we'll have e to the negative 0.17 t. Okay? And you could write that all together. Negative 0.17 t. That's fine. I just like separating it because it helps us make it look like our old school version of this. So what would finding B help us determine? Question? Because this is the rate. This is the continuous rate. Okay? It's not a growth factor. So that would be a growth factor. So this e to the rate is the continuous equation. This then relates to the growth factor. So what would B help us find if we found the value of B? This would be the true change per hour, right? So we can say B equals what? E to the negative 0.17. So what's the true change per hour? So B is 0.843. Someone else get that? So what's the true percent change per hour? The true percent decrease. I heard 15.6%. Someone else get that? So the continuous rate is 17% decrease, but it's truly going down 15.6% per hour. Does that make sense? It's actually going down less than that. Does that make sense? Should it go down more than 17%?
No, continuous should go down.
Should go down more? But as it starts going down, so it's 70% continuously. As it goes down for a while, before 1 hour is up, now what's the new amount? More or less than what we had? Less. So we're taking a percent, we keep taking a percentage, as we compound continuously, we keep taking a percentage of a lesser amount. So then what's the overall effect going to be? Are we going to truly lose 17%? No, because we keep taking take a percent of a lesser and lesser amount throughout that hour. So the true result after an hour is less of a decrease, 15.6%. So how can we write it as B to the T? What should I write there? 0.843. This is really tricky because you got to remember in the old standard form, A, B to the T, that's a growth factor. It's not a rate. That's a growth factor. That's the multiplier. In the e to the kt, that is the rate as a decimal. The continuous rate as a decimal. So you got to know your apples and oranges here. B. So 13 equals, if you can close up quietly, I'll do this while you close up. 13 equals 80 times. Take your pick. You can use either one. Use 8.843. So 0.843 to the t. And now you're solving, you're going to have the log base 0.843 of 13/80ths. Did anyone get that answer? $1.03 per B. Just over an hour to get down to 13 milligrams. No, it should be, that's not right. It's not right. What is it? 10.6. 10.6. Okay, I'll post homework today for Wednesday.
I gotta go write a paper. 700 words. It's not even really good. Nope. That's 5. No. She doesn't really care. As long as you get I only have to take 1 semester and not the full week. It's not this semester. Yeah. 3 copies. I